You drank last night, same as your friend. Same drinks, same pace, same body weight. This morning, the light hurts. You can barely lift your head off the pillow. They went for a 7 a.m. run. We tend to call them lucky, the friend who can drink anyone under the table, who wakes up clean and wears it like an achievement. But everything alcohol research has learned in the last 40 years suggests we have it backwards, because the body that doesn't punish you for drinking is the body that won't stop you from drinking too much. The hangover, it turns out, isn't a sign of weakness, it's a sign of protection. And the people who never feel one aren't winning a genetic lottery, they are missing an alarm system. The story of why leads at one end to the strongest predictor of alcoholism we have ever found. At the other end, it leads to a small mammal still climbing palm trees in Malaysia tonight, drinking the equivalent of 9 beers and showing no sign that anything has happened at all. For most of the 20th century, the hangover wasn't even a real medical topic. It was treated as a moral failing, a punishment for indulgence, beneath serious science. By 2010, only about 400 papers had ever been published on hangover, compared to more than 500,000 on alcohol's other effects. The medical word for it, visalgia, wasn't coined until the year 2000, from the Norwegian kves, uneasiness following debauchery, and the Greek algia, pain. But two things began to change. The first was that hangovers turned out to be measurable. They correlate with elevated inflammatory cytokines, with oxidative stress, with disrupted sleep architecture. They are real in your blood, in your tissue, regardless of how you feel about your behavior. The second was a study published in 2014. Wendy Slutsky at the University of Missouri analyzed data from 4,496 twins on the Australian Twin Registry. She wanted to know how much of the variation in hangover frequency could be traced to genetics. The answer was striking: 45%. About half of why one person crawls out of bed in agony and another goes for a run is written into their DNA before they ever take a drink. So the question becomes, which DNA? In 2008, Jonathan Howland at Boston University ran the numbers across every existing hangover study. Around 23% of drinkers, he concluded, reported being hangover-resistant, people who felt nothing the next morning, no matter how much they had drunk. About 1 in 4. That number became famous. The lucky 23%, the genetic elite who could drink without consequence. But almost a decade later, Joris Verster at Utrecht University did something nobody had bothered to do. He measured how much they had actually been drinking. More than half of them hadn't been drinking enough to give a hangover to anyone. A glass of wine, maybe 2. They weren't resistant, they were just careful. But after that noise was cleared away, a much smaller group remained. People who really did drink heavily, who reached blood alcohol levels well above the threshold for impairment, and who genuinely felt nothing the next morning. These are the people whose biology contains the most disturbing finding in alcohol research. In 1980, a young psychiatrist at the University of California, San Diego, named Mark Schuckett, ran an experiment. He recruited 227 young men whose fathers were alcoholics and 227 men whose fathers weren't. He gave them all the same dose of alcohol, calibrated to body weight, identical down to the milliliter, and he watched. What he saw was unsettling. The high-risk group, the sons of alcoholics, did not feel the alcohol the way the others felt it. They didn't sway as much. They didn't slur as much. They didn't report feeling drunk. 40% of them showed almost no response. Among the controls, fewer than 10% did. Schuckett called it low level of response, a low LR. He didn't yet know what it meant, so he waited. He waited for 30 years. When he checked back on those young men decades later, he found something that has shaped alcohol research ever since. The men who had felt the alcohol least on that night in 1980 were 4 times more likely to be alcoholics by middle age. 4 times. The pattern was so consistent that low LR is now considered one of the strongest known predictors of future alcohol use disorder. Stronger than family history alone, stronger than personality, stronger than stress. The body that does not react to alcohol is the body that will keep drinking it, and it is heritable. About 60% heritable, Schuckett later showed, which means the friend who can drink anyone under the table didn't earn that ability. They were born with it. And they were born with it in the same package as a 4-fold increase in lifetime addiction risk. The hangover is not the punishment for drinking. The hangover is the punishment for being able to stop. Now consider the mirror image. Roughly 540 million people on Earth carry a single mutation on chromosome 12, a G to A swap, in a gene called ALDH2. It was identified in 1981 in a short letter to The Lancet by 3 researchers at the University of Hamburg, Shoji Harada, Dharam Agarwal, Werner Goede. The mutation almost completely disables the enzyme the body uses to clear acetaldehyde, the toxic intermediate produced when alcohol breaks down. In carriers, this is what most people call the Asian flush. One beer, the face turns deep red, the heart pounds, nausea begins, a devastating hangover the next morning, sometimes from less alcohol than a teaspoon contains. In chemical terms, this reaction is almost identical to what disulfiram, the prescription drug Antabuse, does to alcoholics trying to quit. Doctors prescribe Antabuse to make recovering alcoholics feel terrible when they drink. 540 million people inherit some version of the same reaction, for free. And East Asian populations, where the variant is concentrated, have some of the lowest alcoholism rates in the world. Not because of culture, not because of willpower, because the bodies of 500 million people refuse to cooperate with alcohol. Geneticists have traced the variant back to a single ancestor, most likely a rice farmer along the Yangtze River, somewhere around 2,000 to 3,000 years ago. From that one body, the mutation spread across East Asia in the same wave that brought rice agriculture and rice wine. It spread because the people who couldn't tolerate alcohol drank less, lived longer, and had more children. A single ancient farmer, whose body said no to wine, became the genetic ancestor of 500 million people whose bodies still say no. And that same enzyme has another job. It activates nitroglycerin, the drug doctors have used to treat heart attacks since 1876. Up to half of East Asian angina patients don't respond to it. Their hearts don't relax. The mutation that quietly protects them from alcoholism quietly fails them in the cardiac ward. But before any of this could happen, before the Yangtze farmer, before Schuckett's experiment, before there were even humans to flush red, something far older had to occur. 10 million years ago, somewhere in Africa, the common ancestor of humans, chimpanzees, and gorillas was making a transition from the trees to the ground. And on the ground, they began to encounter something they had never had reliable access to before: fallen, fermenting fruit. In 2015, a team led by Stephen Benner at the Foundation for Applied Molecular Evolution did something remarkable. They reconstructed, from the DNA of 28 living vertebrates, the ancient versions of an enzyme called ADH4. They wanted to know how well our distant ancestors could process ethanol. Most of the ancient versions could barely process it at all, but at the branch where humans, chimps, and gorillas split off from other primates, a single mutation appeared. A change in one amino acid, position 294, alanine to valine. And that mutation increased the enzyme's ability to break down ethanol 40-fold. In a single evolutionary stroke, the African great ape lineage became 40 times better at metabolizing alcohol than any of its closest relatives. Not because alcohol was a treat, because rotten fruit, the kind that ferments on the ground for days, was suddenly food. And without that mutation, you couldn't eat it without poisoning yourself. That mutation is in you right now. Every time you take a drink, your liver is using a 10-million-year-old enzyme. But there is a stranger animal still drinking from that ancient inheritance tonight. In the rainforests of West Malaysia, there lives a small mammal called the pen-tailed tree shrew. It weighs about 2 ounces. It looks like a slim, soft-furred squirrel with a long tail tipped in a quill-like brush of feathers. And it shares its body plan with the basal ancestor of every primate alive today, including you. Every night, the pen-tailed tree shrew climbs a burdum palm and presses its mouth into the flower buds. The buds are colonized by yeast. The yeast ferments the nectar inside, sometimes up to 3.8% alcohol, about the strength of a beer. The tree shrew drinks for an average of 138 minutes, sometimes longer. By human body weight equivalent, it consumes the alcohol of around 9 beers in a single night. It does this every night of its life. It shows zero behavioral signs of intoxication. It walks, it climbs, it forages, exactly as it would sober. Its hair, when measured, contains higher concentrations of ethyl glucuronide, the metabolic fingerprint of alcohol, than the hair of chronic human alcoholics. The German biologist Frank Wiens documented all of this in 2008 in the Proceedings of the National Academy of Sciences. His conclusion was that this animal is doing tonight what your distant ancestors were probably doing 55 million years ago, drinking the slow ferment of forest flowers. Every night, as normally as you drink water. You are descended from a creature like this, and the enzyme that lets you sip a glass of wine at dinner is the same enzyme that lets it climb that palm. So here is what the science quietly says. The hangover is not weakness, it is not punishment, it is not bad luck. The hangover is your body, with 10 million years of evolution behind it, refusing to keep cooperating. It is a message, written in nausea and headache, sent across deep time, from a system that has decided you have had enough. The friend who never gets that message is not luckier than you. They are quieter. Their alarm doesn't ring. And the cruelest thing about the science is that the people for whom it never rings are the people who most need it to. If you woke up this morning feeling terrible, your body did something for you that 540 million people would recognize. It said no, and it meant it.